Hello, hi there. Just give me a second. I'm changing my applications. Yeah, just a second. Okay, so it's on. Okay, yeah. For now, we will be doing our first test case, which is just simply getting the flashing the firmware. In the background, I'm just connecting with my MQTT servers. First is the meta and second is the payload. Meta is the one which sends all the CRC check and everything. Yeah, so meta payload. For now, I'm using CJSON inside this to extract the text from the JSON, and meta just for now contains single JSON object with key as a message and value as CRC field, as we'll be seeing right now. As you can see, we have the meta called as topic name. We will generate the CRC right now. I'm using something called as 7z. It gives the value in hex. We will just convert this hex to unsigned integer. I have a website for this. Let's go to the site. It's unsigned because it was coded in the ESP32 that way. Let's copy and send it to the MQTT. It has sent. Let's verify on the ESP board. The controller has got the value. The CRC is -20, the rest of it. Now let's see the hex dump of the firmware using the XXD command. Oh, it's a Windows. Let me just switch to the bash. Just a moment. Yeah, so this is the complete firmware.bin in the hex format. As we just extracted it, now we have to send this to our MQTT server. What was the command? Just a second. Alright, it's in the download folder. Yes, just give me a sec. Yeah, here it is. This is the command to send the hex data. The data is in binary format. Let me just change it to the real topic name, which is firmware payload. We have used the meta for sending the CRC, and now we are using the payload topic. As you can see, it has sent it, and The target was the firmware which we sent at the version 2, and the current version running on the STM32 is version 2 itself. This is the first feature of the code. It will simply skip the upgrade if the same CRC is found to be exactly same for the current and the new firmware. We could have used the firmware meta version, but it is not 100% accurate. The 2 here which you are seeing is the version name, which is at the address 0x800 and the offset is 200. And how do I know this? Let me just open it up. Oops. Yeah, here is the firmware memory layout. This is of the STM32. And why STM32? Because the ESP32 is flashing the STM32 firmware using UART protocol. To avoid the overlap, hence we are starting at 200 offset. Above 200 is the 0 to 100 and 100 to 200 is the offset for the flash. The flash origin at 100 offset and 100 to 200, and then the 200, from 200 it starts the firmware version, and the rest and the next at the memory table it has the entry for text and BSS, the rest of the memory layout. As you can see, we have just skipped the update because the firmware was exactly same. The firmware version and the new firmware version were same, and even the CRC was same. We found the CRC using something called as read memory. We use UART protocol to get the memory dump, and we compared it with the memory dump of the new firmware. Now what I am doing is building the new firmware, which is firmware 1. Previously I was using firmware 2, as you can see here. Now I have changed to firmware version 1. Just a moment. Oh, this is the something was wrong with the project. I will be re-recording this flash building process and just over the next video. Okay, so we are back, guys, and this is the new recording. Let me just check everything is right before I build it. So as we can see, the bare LED version is now at low mode just for the testing purpose, and the version is, I'll be getting right away. The version is 1, as you can see. Now let's quickly flash this firmware. The process is same. We will first search the CRC build as seen earlier, and next we'll be sending the payload itself in the hex. Everything remains the same. The only one part different is the firmware version was previously it was 2, now we are sending the 1. Let's hope it works. We have got the firmware right now. It's flashing. It actually masks erases it. It takes some time and then it flashes. Yeah, here it is. So you can see previously the CRC was -2 and the new is in the positive range, and it even after the flashing we can see the CRC remains the same. The CRC bits you can see here, it does in two way. First is it will check. Oh yeah, just a second. Let's just read the current dump, and we will see it is at version 1. This is a live dump with the STM32 is on. I got this value from the programmer ST-Link CLI to read the dump after it has been flashed. So we have successfully flashed the firmware using UART. Currently it has the features to skip the upgrade based on CRC and flash it after the CRC is passed and everything is good. So that's it. Thank you guys.